Welcome to the deep dive. Today, we're really plunging into the heart of cybersecurity, looking at Linux specifically for hackers.
Yeah, it's a foundational topic.
Absolutely. We've got a great set of resources you sent in Ty Darwin's Linux for Hackers, Occupy the Web's Linux Basics for Hackers, some really useful YouTube clips, and even a quick look at relevant hashtags.
A good mix.
Our mission really is to pull out the essential knowledge from all this.
Yeah.
We want to give you a clear sense of why Linux is so central to hacking, but, without getting lost in the weeds.
Right, cut through the jargon.
Exactly. We'll unpack the kind of control Linux offers and, crucially, why the vast majority of hacking tools are actually built for it.
It's not accidental, that's for sure. The
Yeah.
flexibility and power are just inherent to Linux, which is why it's so dominant in cybersecurity.
Okay, let's get into it then. One thing that just jumps out from all the sources is this idea of granular control. Occupy the Web puts it nicely, an almost infinite amount of control over the system. It's like, well, think about other operating systems. They often give you tools, but you work within their limits.
Yeah, a walled garden, sort of.
Right. Linux is more like having a whole workshop. You get all the parts, you can build, you can customize exactly how you need it. And that level of access, it's not just for fun, it's critical for understanding how systems really work.
And for finding weaknesses, yeah.
Uh.
Which ties directly into the tools, doesn't it?
He does.
Our sources consistently point out like over 90% of hacking tools, they're written for Linux.
90%? Wow.
Yeah. And even if you find versions for Windows or Mac OS, they often, well, they lose some functionality.
Yeah.
It's because those systems just don't allow that same deep, low-level interaction.
It's like trying to do surgery with boxing gloves on, maybe.
Yeah, something like that. You lose the precision.
So if you're listening and thinking you want to dive in, experiment a bit. Occupy the Web has a strong recommendation.
Kali Linux, right?
Exactly. Kali Linux. It's not just another Linux distribution. It's specifically built for pen testing, for digital forensics.
The big advantage, as Linux Basics for Hackers really stresses, is that it comes packed with tools already installed.
Huge time saver.
Massive. Instead of setting up standard Linux install and then spending hours, maybe days, finding and installing everything.
It's just there. You can grab it straight from kali.org.
And the best way to run it, usually, especially when you're starting out, virtualization.
Right, setting up a VM.
Yep, a computer inside your computer. VirtualBox. Now, Oracle VM VirtualBox is a great free option. Lets you run Kali safely inside your Windows or Mac system.
Good point about safety. And resource allocation is key there, isn't it?
Definitely. The advice is generally not to give the virtual machine more than, say, 25% of your system's RAM.
Okay.
Keeps your main computer running smoothly, doesn't bog it down.
Makes sense. And you also need to check your hardware, right? And make sure virtualization is actually enabled in the BIOS.
Crucial step. It's usually off by default on many systems. You might have to go into your BIOS settings when you first boot up the computer.
And sometimes disable other things, like Hyper-V on Windows if it conflicts.
Yeah, they don't always play nice together.
Yeah.
A quick web search for your specific machine usually finds the instructions.
Okay, so you've got Kali running in a VM. First concept you'll likely bump into is the root user.
Ah, yes, root, the super administrator. Similar to administrator on Windows, but more powerful, really.
And a lot of the hacking tools, the system commands, they need those root privileges to work properly.
Absolutely. You can always check who you are with the wuami command in the terminal. Simple but useful.
And then there's the file system structure. It's fundamental.
It is. Everything starts from the root directory, just text. Like the C drive, but for the whole system.
And from there, you branch out. You've got root. That's the root user's own home folder.
Etc., which is super important. That's where most configuration files live. System settings, software settings.
Right. And home is where folders for regular users go. And MNT is typically for mounting things like USB drives.
Exactly.
Navigating this, it's all done mostly through the terminal, like the pan line.
Goreskill.cd for change directory. That's how you move around.
Yeah, there are L's to list what's in the directory you're in.
And else, -L gives you the long format permissions, owner, size, date, all the details.
Yeah, is useful too. Shows hidden files, right? Things starting with a dot.
Yep, often config files.
Yeah.
And if you get lost, PWD, present working directory, tells you exactly where you are in that tree structure.
Super helpful. And what if you don't know how to use a command?
Ah, the built-in help. Almost every command has it. Try typing the command, then help.
Okay.
Or even better, man followed by the command name. Man-ls, for example.
Command for manual pages.
Exactly. Gives you a full breakdown, options, examples. Really comprehensive.
Okay, so finding files, dot, Locate is one way.
Yeah, locate is quick because it uses a database that's updated periodically, but it might not find brand new files immediately.
So for more precise searching.
Find. Much more powerful, much more flexible. You tell it where to start looking, like find, etc. You can specify the type, like any type F for files, and the name, name config, for instance.
And it supports wildcards, like the asterisk.
Oh yeah. Find home-name.txt would find all text files in all home directories. Very useful.
Right. Now, what about seeing what's actually running on the system? Processes.
Process management, yeah. Key for security, too. PSO shows you everything that's running.
That can be a lot of output, though.
It can. So you often pipe it, use the symbol into grep, like PSO grep Apache 2 to find Apache processes.
Gotcha. And for a live view.
Top. That's your real-time dashboard. Shows CPU usage, memory usage, which processes are hogging resources, updates constantly.
Essential for spotting trouble.
Okay.
Okay, let's shift gears slightly. Working with text files, you do a lot of that, right? Logs, configs.
Constantly. Cat is the simplest. Just displays the file content to the screen.
Cat file name.
Yep. And you could redirect that output, use it to send it to a new file, overwriting if it exists.
Or to append, add it to the end of a file.
Exactly. Now, if you just want to peek at the start or end, head and tail.
Head for the beginning, tail for the end. Default is 10 lines.
That's right. But you can change it with NN. Like tailman1020 varlog syslog shows the last 20 lines of the system log. Very handy for watching logs update in real time.
And NL adds line numbers.
It does. NL file name. Useful if you need to refer to specific lines, maybe in a report or discussion, often paired with grep.
Ah, grep, the text searching tool.
Super powerful. Grep keyword file name. Filters lines containing that keyword. You can use complex patterns too, regular expressions.
And there's S, the stream editor. Sounds more advanced.
It is. Great for find and replace jobs. The basic syntax is like sed, sold text, new text, G, input file, output file.
S for substitute, G for global replace on each line.
You got it. You can omit the G to only replace the first match per line or use a number for a specific occurrence.
And for just viewing big files easily.
It's less. It's interactive. Lets you scroll up and down using arrow keys or page up down. You can search using then your search term and N jumps to the next match. Much better than cat for large files.
Okay, file management basics. Creating directories.
mkdir directory name. Simple enough.
Topping files.
CP source file destination. Like cpconfig.txt, backupconfig.txt.
Yeah.
You can copy to another directory too. cpreport.pdf, home user documents.
And moving or renaming.
MV does both.
Okay.
MV, old file name, new file name renames it. MD file to TXT, TMP moves it to the TMP directory.
And deleting, the scary one.
Huh, yeah. RM file name removes a file. RM-R directory name removes a directory and everything inside it, precursively.
You're careful with that one.
Very careful. No recycled in by default in the terminal.
Yeah.
When it's gone, it's usually gone.
Okay. Permissions. This seems really core to Linux security.
Absolutely fundamental. LSL shows them. You see 9 characters, right? Like RFC, RDAX,
3 groups of 3. Owner group, others.
Exactly. Read R, write W, execute X.
Yeah.
A dash means the permission is denied.
And the numbers. 4, 2, 1.
Right? R4, W2, X1. You add them up for each group. So RWX is 4 plus 2 plus 1 equals 7. RWX is 4 plus 0 plus 1 equals 5. R is 4 plus 0 plus 0 plus 0 plus 4.
So chmod 754 full name would set RWXR-XR.
Precisely. Chmod changes the permissions, and chown changes the owner. CRP changes the group.
Got it. Let's talk networking, ifconfig.
Your main tool for viewing network interface details, IP address, MSE address. You can also use it to bring interfaces up or down, like ifconfig eth0 down.
Useful for troubleshooting or changing identity.
Yeah, sometimes. And dig is for querying DNS. Diggoogle.com will show you IP addresses associated with google.com. Diggoogle.com, MX shows mail servers.
And you can manually set DNS servers.
Yep. Edit the acresolve.com file. Put your preferred DNS server IPs in there.
Or map names to IPs directly.
And XYosts. You can make your system think some site.com points to its specific IP.
Yeah.
Useful for testing or blocking.
Okay. Software management on Kali, which is Debian-based, uses apt-get.
That's the classic tool, yeah. apt is often used now too, a bit more user-friendly, but apt-get is still very common.
So apt did update first.
Always. Refreshes the list of available packages from repositories.
Then apt-get search package name.
To find software.
Apt-get install package name to install it.
Correct. And apt-get upgrades all your installed packages to their latest versions.
And where does he get these packages from?
The repositories listed in etcapsources.list. That file tells your system where to look for software.
Right. Automation now. Bash scripting.
Super useful. Even simple scripts save time. It's just a text file with commands.
Start with #binbash. The shebang.
Usually, yeah. Tells the system, use bash to run this.
Echo displays output. Hashtag starts a comment.
Yep. And you make it executable with mojwad plus X script name.
Then run it with .script name.
That's it. You can use variables too.
Mm-hmm.
myvar some value,
Mm.
no spaces around the lobber. Access it with myvar.
And get input from the user.
Read variable name, pauses the script, waits for the user to type something, and press enter, then stores it in the variable.
Okay, handy. What about packing files up, archiving and compression?
tar is the main archiving tool. Creates a tarball, a single file containing others. tar-cvf archive.tar file 1 file 2 dir1.c for create, v for verbose, show files, f for file name.
And extracting.
tar-dag xvf arcos.tar.x for extract, -tvf just lists the contents without extracting.
And compression.gzip.
bzip file name creates file name .gz, gunzip file name .gz extracts it.
bzip2 is similar .bz2 file.
Yep, often gives better compression than gzip, bzip2 file name, bunzip2 file name .bz2.
What about compress.tarz?
Older format, less common now, less efficient. Compress and uncompress, you probably won't see it much.
And DD, that sounds serious.
It is. Low-level copy tool.dd. If divsdav devsdb, bs4am, confinoware, makes a bit-for-bit clone of one drive, devs to another, devsdb, vs a block size, again, where error keeps going if it hits read errors. Crucial for forensics.
Okay, log files, why are they so important?
They record everything. System events, logins, errors, service starts, stops, potential security issues. Analyzing logs is a huge part of security monitoring and investigation.
Configuration is in edit.shareSizeLog.com.
Usually, yeah. Controls what gets logged and where. And logrotate manages log file size and rotation, configured in edclogrotate.com. Stops logs from filling up the disk.
And secure deletion, if AM isn't enough.
Shred. Shred an SN3 file name. Overwrites the file's data multiple times, SN3 means 3 times, before deleting, making recovery much harder. And F forces it if permissions are tricky.
Right. Let's touch on some specific security and anonymity tools mentioned. VPNs.
Virtual private networks. Encrypts your traffic, route it through a VPN server, hides your real IP, makes you appear to be wherever the server is. Good for privacy and security on untrusted networks.
Proxy servers.
Kind of an intermediary.
Yeah.
Your request goes to the proxy forwards it using its own IP. Can mask your origin, but some proxies log activity, so choose carefully. Tools like proxy chains let you chain multiple proxies together.
And Tor, the onion router.
High anonymity. Bounces your encrypted traffic through multiple volunteer relays around Midfielder's world. Each relay only knows the previous and next hop. Makes tracing back very difficult. The Tor browser is needed to access onion sites on the dark web.
OpenSSH.
Secure shell. Encrypted remote login. Replace the old insecure telnet. Essential for managing remote Linux servers securely.
Okay, network monitoring tools.
TCP dump.
Captures raw network packets. Lets you see exactly what's going across the wire. Very detailed, requires understanding network protocols.
It's all stuff.
Lists open files. But since Linux treats network connections like files, it also shows open network sockets and which processes are using them. Traces system calls. Shows the low-level requests a program makes to the operating system. Great for debugging or reverse engineering malware.
The netstat.
Shows network connections, listening ports, routing tables, interface stats. Gives a good overview of network activity.
VMstat, ifstat, mstat, more monitoring. Yeah, performance-focused. VMstat for virtual memory. Ifstat for real-time network interface traffic. Mstat for CPU statistics on multiprocessor systems.
Now, on to the more active side. Exploitation tools. Metasploit comes up a lot.
Huge framework. Contains tons of exploits, payloads, auxiliary modules for penetration testing. A standard tool for ethical hackers and, well, others too.
Web application analysis. Burp Suite.
The go-to tool for web app security testing. Acts as a proxy, lets you intercept, inspect, and modify HTTP requests and responses between your browser and the web server. Finds vulnerabilities like SQL injection, cross-site scripting.
And Wi-Fi hacking basics. Air cracking suite.
Yeah, tools like AeroDumpon capture Wi-Fi traffic and discover networks clients. Air cracking tries to crack passwords, usually WPK2, by capturing the handshake and running dictionary or brute force attacks. Needs things like the BSSID, AP's MNC, a client may see the channel.
Requires specific hardware sometimes too, right? Wireless cards that support monitor mode.
Absolutely, not all cards do.
Okay, last big topic from the sources. Python for hackers.
Very popular. Relatively easy to learn, readable syntax, and tons of libraries for everything from network scanning to web scraping to exploit development.
Installing libraries uses pip3.
Yep, pip3 install requests, pip3 install escapee, whatever you need. It's the package manager for Python 3. Packages usually go somewhere like us local Python version disk packages. pip3 show package tells you where.
And Python scripts are just .py files run with python3 script.py.
Basically, yeah. You'll use text editors to write them.
Key concepts mentioned: variables, comments, hashtag, function.
Standard programming stuff. Variables hold data numbers, text, lists. Comments explain the code. Functions, bundle reusable code.print is a built-in function.
Modules for extra functionality, like import socket.
Crucial. Python's power comes from its extensive standard library and third-party modules. Socket is fundamental for any network programming.
And object-oriented programming, OOP. Classes, objects.
Yeah, helps organize larger programs. Think of a class as a blueprint, like car, and an object as an instance, like me-specific car. Methods are actions the object can perform.
Control flow, if-else, loops.
Essential for logic. If statements make decisions. For and while loops repeat actions. Try dot, except handles errors gracefully.
And that socket module lets you build network clients and servers in Python.
It does. You can create connections, send and receive data over TCP or UDP, the foundation for many custom hacking tools.
Okay. Looking ahead, the sources paint a picture of a dynamic landscape.
Constantly changing. More state-sponsored activity. Focus on cryptocurrency attacks.
Ethical hacking, white hat hacking, seems more important than ever.
Definitely. Organizations need skilled people to find vulnerabilities before the bad guys do. Staying current with threats, tools, and even AI's role in cybersecurity is key.
It really feels like understanding Linux is table stakes for serious work in this field.
It truly is. That foundational knowledge of the OS, the command line scripting, it underpins so much of modern cybersecurity practice.
Okay, let's try and wrap this up. We've covered a lot, from why Linux gives you that deep control to the tools like Kali, navigating the file system, managing processes, manipulating text, networking basics, scripting.
Wow, it's a broad foundation.
And hopefully you can see how these seemingly simple commands, brep, cd, shmode, aren't just isolated things. They're the building blocks.
Exactly. You combine them, you script them. That's where the real power comes in for security tasks, analysis, automation, defense, even offense. Understanding how the pieces fit is key.
So what does this all mean for you listening? Hopefully this deep dive has, maybe sparked some curiosity, giving you a clearer map of this territory.
It's just the start, though.
Absolutely. The best way to learn this stuff is by doing. Get a VM, install Kali, try these commands out safely, maybe write a simple bash script or look at some beginner Python network examples.
Don't be afraid to experiment in that safe environment.
Exactly. So here's a final thought to maybe chew on. In this world that's just getting more and more connected, more complex digitally, how does really understanding an operating system, getting down to the nuts and bolts like you can with Linux, how does that fundamentally change how someone can both see the vulnerabilities and participate in actually defending that digital world?
That's a great question. It shifts you from just being a user to potentially being a builder, a defender, an informed analyst. It's about agency, really.